Hi there. Welcome to the practice questions on being able to solve quadratics by factorising. What I'd like you to do now is to pause the video, have a go at the three questions, then when you're happy with your answers, then restart the video and go through the model answers with me. So pause the video now, have a go at questions 1, 2 and 3. Hi, welcome back. Let's now go through these three questions together. Okay, well we've got a quadratic equation here, question 1. With a quadratic, to be able to solve it, it must be equal to 0, which it is. And what we need to do first of all is factorise this. We're going to look for two numbers that multiply to give negative 20 and that add to give negative 8. Now my two numbers, I could have 1 and 20, I could have 2 and 10, or I could even have 4 and 5. It's the second set that are going to add to give negative 8. But remember, one of these must be positive, one of these must be negative to give the negative answer here. So it's going to be a positive 2, add negative 10, gives me negative 8. So here I just now open up two sets of brackets. Whatever the letter is here, in this case it's x, I write at the front of the brackets. And then whatever my numbers were here, I write x plus 2 in the first one and x minus 10 in the second one. Now it doesn't matter what way round you do these, you could have written x minus 10, x plus 2, but you must have the signs correct. Now that is equal to 0. So all I've done so far is I've factorised this and set it equal to 0. Now what I need to do is write x plus 2 equals 0. And I've done this because if you remember, if you've got two numbers and you're multiplying them together, to get rid of one of those, to get rid of the multiplication, you must divide both sides. So here, to get rid of this x minus 10 and leave the x plus 2, I should be dividing both sides by x minus 10. But of course 0 divided by x minus 10 is 0, so it's just disappeared. So I'm left with x plus 2 equals 0. Now I could have done it the other way around. I could have divided both sides by x plus 2, and then 0 divided by x plus 2 would have left me with x minus 10 equals 0. Now, if I then solve these similar equations by taking the 2 over to the other side, taking the minus 10 over to the other side, my answer's just going to be x equals negative 2 and x equals positive 10. Now you don't really have to go through this process when you've got a simple one like this. All you can see that's happened is once I've factorised it to get the answers, I've just changed the signs for each of them. Okay, question 2 then. Now this time it's not equal to 0. So in order to solve this, we've got to start off by making this equation equal to 0. Well, that's easy to do because if I just take away 4 from here, I've got 0. But whatever I do to that side, I must do to the other side. So I'm going to take away 4 from the left-hand side as well. That's going to leave me with x squared minus 6x minus 40 equals 0. Now I'm in the same situation as I was in question 1. So two numbers that multiply to give negative 40. Well, I could have 1 and 40. I could have 2 and 20. I could have 4 and 10. Or I could have 5 and 8. It's clear to see here that 4 add 10 is going to give me a difference of 6. So all I need to decide is which one's the negative, which one's the positive. Because remember, it's got to be a negative 40. So if I've got negative 4 add 10, that's going to take me to positive 6, so it must be positive 4 and negative 10. So I write this down in my double brackets, x plus 4 in one set and x minus 10 in the second set. That's equal to 0, and remember in this situation to get the answers I can just change the signs. So x equals negative 4 and x will equal positive 10. Okay, question 3 now. This is more complicated because it's got the coefficient in front of the x squared term. In this situation, the first thing I do is I multiply the 3 by the 12 to give me 36. I'm now looking for two numbers that multiply to give 36 and add to give 13. Okay, well the combinations I could have would be 1 and 36, I could have 2 and 18, I could have 3 and 12, or I could have 4 and 9. Now, it's pretty easy on this one to see that this could not possibly add to give 13, this doesn't add to give 13, this doesn't add to give 13, but the 4 and the 9 do add to give 13. So these are the numbers we're using. But this time we've got some more steps. We need to start off by splitting the middle number, the 13x, into our new numbers we've found, the 4 and the 9. Write the equation out again, but split the 13x into 4 and 9. So I get 3x squared plus 9x plus 4x plus 12, and that equals 0. I've written it this way around because I want the first two numbers to be easy to factorise together and the second two numbers to be easy to factorise together. If I wrote the 4 here, I'd have 3 and 4, and that doesn't factorise. So what I now do is I do something called pairing. Split this down the middle, and I've got this as one pair and this as another pair of numbers. So if I look at factorising this pair first of all, what is a factor of both 3x squared and 9x? Well, it's 3x. So I'll write 3x, open up my brackets, 3x times x gives me 3x squared, and 3x times 3 gives me 9x. Do the same with the second pair. Well, what occurs in both? Well, 4 is a factor of both. 4 times x gives me 4x, and 4 times 3 gives me 12. These numbers inside, or these expressions inside the brackets, should always be the same. Then you finish off by writing whatever's outside the brackets, 3x plus 4, in one set, and whatever's inside, and remember they must be the same, in the other set. And that then is equal to 0. Now this time it's not just a case of changing the signs, because if you look here, if we divide both sides by x plus 3, I'm going to be left with 3x plus 4 equals 0. So I've got a little equation to do here. Take 4 away from both sides, which is going to give me 3x equals negative 4, and then divide both sides by 3, so that's going to leave me negative 4 over 3, or negative 1 1/3. The other one's pretty straightforward because x plus 3 equals 0, so x must equal minus 3.